we're going to look at some simplifying expressions with exponents, but especially more challenging ones. So you can tell on this is a more challenging one because of this minus and plus. It's not as straightforward. And because that minus and plus, you can't move any of these negative exponent pieces up or down. What we can do is go 1 over a plus minus. Minus 1 over b, 1 over a plus 1 over b. So when we take a look at that, we can see that this is a complex fraction. And in our complex fraction, we can multiply top and bottom by that least common multiple. What I would do here is multiply by ab on the top and bottom. And at that point, you're going to get ab over a minus ab over b over ab over a plus ab over b. And here you can see those cancel, those cancel, those cancel, those cancel, and we end up with b minus a over b plus a. Now, one kind of caveat we might add is we might have to add a can't be 0 and b can't be 0, and that a can't equal negative b, but that would depend on the direction. So if the directions on the problem said assume all variables are positive, these would not be needed. Okay, so this is another one where I've got some negative exponents, and what we're going to do here, okay, and again, you can see the same thing that I'm talking about, how I have a minus here and a minus there, and those minuses are making the problem more challenging. So what we're going to do now, because I have something that is 2 terms multiplied by another thing that's 2 terms, is we're going to FOIL. So we're going to do our first outer, and I'm just going to write z times z to the negative 1 for right now. Inner and last, and then minus times a minus. Now, here we're going to get z w to the negative 1 minus z to the 0 minus w to the 0 plus this. We don't want any negative exponents, so I'm going to write this as z over w minus 1, because z to the 0 is 1, w to the 0 is 1, and w over z. So this is one way to write this. And I would consider this a simplified form. But we might also get a common denominator and write as a single fraction. That would also be considered simplified, which is kind of a funny thing about the word simplified. It's a little ambiguous at times. If I did that, this one would need a z, this one would need a zw, and this one would need a w. So I would have z squared minus 2zw plus w squared over zw. I would accept either one of these as a simplified. This is just simplified, and this would be simplified as a single fraction. All right. Oh, here's another one. Now this one's even trickier. So again, I have addition and subtraction signs, but I also have this negative 1 on the outside. That cannot distribute in, as tempting as it is to distribute it. So what I'm going to do is I'm going to rewrite d to the negative 1 as a 1 over d. Then I'm going to write e to the negative 1 as a 1 over e. And then this d plus e all to the negative 1, that's going to be 1 over d plus e, because that whole quantity needs to move down. Now, in order to add 2 fractions, I need a common denominator, which means this guy needs an e on top and bottom, and this one needs a d. And so I have e plus d over that de times 1 over d plus e. Now, e plus d and d plus e really are the same thing because addition's commutative. I can add in either order. And what you can see now is that d plus e on the top and bottom canceling. Again, because we are going to assume that that our variables are positive, that's most likely what the directions would say. I'm not going to write any restrictions on this, but if we didn't have that disclaimer, then we would want to state our restrictions that D can't be 0, E can't be 0, and D can't equal negative E. All right, one more. So, 2 times 4 to the k plus 4 to the k. Here, this is a really tricky thing. So what I'm going to do for a moment is I'm going to look at, instead of 4 to the k, if I had k to the 4th plus another k to the 4th, k to the 4th plus k to the 4th is 2k to the 4th. We don't change the base, we don't change the exponent. We just have 2 of them because it's like one apple and another is 2 apples. So what I'm going to do here is I'm going to have 2 times 2 times 4 to the k. Now, 2 times, this is all really just 2 times 2 times 4 to the k. And because these are just 2 times 2 regular, I can say that as 4 times 4 to the k. And that will be 4 to the k. Alternatively, I also could have done, starting at the same spot, 2 times 2 times 4 to the k. I could have rewritten that 4 to the k as a power of 2. So 2 times 2 times 2 squared to the k. 2 to the first times 2 to the first times 2 to the 2k. When I multiply and I add my exponents, and that's going to give me 2, which is 2k plus 2. Either one of those answers would be valid. I got one more. I want you to pause the video right now and see if you can do this one. Hopefully you've tried it. Okay. So here we have 27, and then here I have 3 of these 3 to the k's. I'm going to rewrite 27 as 3 cubed times 3 to the first times 3 to the k. Since my base is all 3, because we're all about that base in exponents, let's say k plus 4. We're going to add all those exponents. That concludes this quick little tutorial of these more challenging exponent problems with addition signs. Hope this helps.